All right, so today we're going over 7.2 notes. Yesterday we solved our systems of equations by substitution. Today we're going to solve by elimination. So we just add our two equations together, and our goal is to eliminate one of our variables. So in order to eliminate a variable, we need the same number, but they have to be opposite. So looking at example 1, right off the bat we can eliminate the y's because we have a positive 2 and a negative 2. So we're just going to add everything in our equation together. So what's 3x plus 5x? 8x. 2y minus 2y cancels out. And then this is equal to 4 plus 8, which is 12. Divide both sides by 8. So x is equal to 3 over 2. Perfect. How do you think we find what our y is? Plug it in. Do you want to plug it into the first or the second? It doesn't matter. We can plug it into either one. Anna says let's plug it into the first. So as long as we plug it into x, because we found x, so we have to plug it into x. So we have 3 times 3 over 2 plus 2y is equal to 4. How do we solve for y?
Distribute the 3 to 3 halves.
How do we multiply 3 times 3 halves? When
Is
multiplying,
3 over 1 times 3 over 2.
right, 3 over 1 times 3 over 2. When multiplying, you don't need the same denominator. You just multiply the tops together, multiply the bottoms together. So this would be what? 9 over 2. Plus 2y is equal to 4. Whenever I see a fraction in an equation, I don't like working with fractions, so it helps if I just multiply everything by the denominator to get rid of it. So I'm going to multiply everything in my equation by 2. Because that way these cancel, so I'm just left with 9 plus 4y is equal to 8. So instead of subtracting the 9 over 2 to the other side and then doing 4 minus 9 over 2, getting some type of fraction, it's easier just to get rid of your fractions. What can we do next?
Minus 9.
Subtract 9. So we have 4y is equal to, what is 8 minus 9? Negative 1. What should we do next? Divide both sides by 4. What do we get for y? Y is equal to negative 1/4. Now, just like we did in solving systems of equations with substitution, we have to write our answer as a coordinate pair. So this would be 3 halves, comma, negative 1/4. So always list your x first, then your y. All right, let's look at example 2. So sometimes we're not as lucky where we can just cancel them out right away. Sometimes we have to multiply one of our equations by something to get the same number but opposites, so they'll cancel. So what should we multiply and by which equation to get what to cancel here? Negative 2 to the first equation? We can either cancel out the x's or cancel out the y's. If we want to work with the x's, we could multiply the top one by negative 2 and the bottom one by 5. If we want to cancel out the y's, we could multiply the top by 4, the bottom one by 3. So our options are limitless here. Do you want to cancel out the x's or the y's? Just pick one. Let's cancel out the x's. So what do we need to multiply by our first equation? Negative 2. So multiply by negative 2. Times negative 2 and times negative 2. So our new first equation becomes negative 10x minus 6y is equal to negative 18. What do we have to multiply by the second equation? 5. So everything gets multiplied times 5. So this is 10x minus 20y is equal to, what's 14 times 5? 70. Perfect. Can we combine our two equations now? Yep. So what happens to the x's? They cancel. What's negative 6y minus 20y? Negative 26y. And then what's negative 18 plus 70? 52. What do we do next? Divide both sides by 26, so y is equal to negative 2. Perfect. How do we find the x? Plug it in. Let's plug it into the bottom one. So it doesn't matter which equation we plug it into, as long as we plug it in for y, because we just found y. So 2x minus 4 times negative 2 is equal to 14. What do we do first? What's negative 4 times negative 2? Positive 8. What's next? Subtract 8. So 2x is equal to 6. X is equal to 3. So how do we write our answer? What comes first? 3, comma, negative 2. Awesome. Okay, so our graphs of systems of equations, if we have one solution, our two lines intersect at one point. So our two lines for our equation intersect here. Whatever that point is our answer. If those two lines overlap completely, so two lines right on top of each other, then we have infinitely many solutions. And if the two lines are parallel, that means they'll never touch, then we have no solutions. So for example 3, we have to match each system of linear equations with its graph and describe the number of solutions, then state whether the system is consistent or inconsistent. So first let's find how many solutions we have. So we're just solving this the same way we did in the first two examples. So for A, what do we need to do first? Do you want to cancel out the x's or the y's? The y's? Sure, let's cancel out the y's. So what do we have to multiply? Because these numbers aren't the same. So we're going to have to multiply the first one by something. What is that something? By 2. So multiply everything in our first equation by 2. So our new first equation is 4x minus 6y is equal to 6. Now that we see our y's are going to cancel, we can go ahead and combine our equations. So it's negative 4x plus 4x. 0. Our y's cancel. And what is 6 plus 6? 12. Does 0 equal 12? Nope. So what do you think our answer is here? No solution. So looking at our graphs, which graph does this go with? The middle one. It means our lines are parallel, they never touch because we have no solutions. All right, let's look at B. What do you want to cancel, the x's or the y's? The x's. So we have a 2 and a 1. What do we have to multiply by the second equation to get that to be a negative 2? A negative 2. So multiply everything in our second equation by negative 2. So our new second equation, I'm going to write it up top here. It's going to be negative 2x minus 4y is equal to negative 10. So I just rewrote it up here. Now we see our x's are going to cancel, so we can go ahead and combine everything. X's cancel. What's negative 4y minus 3y? Negative 7y. And then what's negative 10 plus 3? Negative 7. Divide both sides by negative 7, so y is equal to 1. How do we find what x is? Plug it in. Do you want to plug it into the first or the second? Sure. Second looks a little bit easier. Let's plug it into the second. So we have x plus 2 times 1 is equal to 5. How do we solve for x? Subtract 2. So x is equal to 3. So what's our answer here? 3, 1. So let's look for our graph that intersects at 3, 1. Which graph is that going to be? The third one. All right, let's do C. Do you want to cancel out the x's or the y's? Sure, let's cancel out the x's. What do we have to multiply by which equation to get 2 times the first one? So our new first equation becomes 4x minus 6y is equal to 6. Our x's cancel. What's negative 6y plus 6y? 0. And what's 6 minus 6? 0. So when we get 0 is equal to 0, what do you think our answer is? Infinite solutions. I think I spelled infinite wrong, but it's fine. Infinitely many solutions. So which graph do you think that is? The first one. Any questions on example 3? Do you want to cancel out the x's or y's? What do we have to multiply by which equation to get our x's to cancel? The top one by 2. So our new top equation is going to be 2x minus 4y is equal to 6. Our x's cancel. What's negative 4y plus 4y? 0. What's 6 plus 1? Does 0 equal 7? So what's our answer? No solution. Any questions on this one? Last example, yay. What do you want to cancel, the x's or y's? What do we have to multiply and by which equation to get the x's to cancel? Negative 2 on the first one. Negative 4x plus 2y. Yep. Infinite solutions.